We begin our studies of conic sections with a little bit of an overview. Most often when we think of a cone, we just think of this basic shape here that I'm outlining, which is the ice cream cone sort of a shape. But technically a cone has this bottom half to the shape also. When we are finding a conic section, we are taking a plane here and we are slicing through the cone with it, kind of like a magician would take one of those metal plates and supposedly push it through the victim or assistant, I should say. What we are interested in here in the outline of the shape that is formed with the intersection of the cone and that plane. When the plane is perpendicular to the axis which is running through the cone, then this outline here is in the shape of a circle. When the axis of the cone is not perpendicular to the plane, then the circle becomes slanted or ovular, and we call that shape an ellipse. Notice how it's spelled. It is not an eclipse with a C, it is an ellipse, E-L-L-I-P-S-E. When the plane that is intersecting this cone is parallel to the axis through the cone, then you get these two curves drawn out here, which together are a hyperbola. Don't get that mixed up with a hyperbole, an exaggeration, in your English class. And also do not get these curves confused with a parabola. This is not two parabolas pointing away from each other. It is its own shape with a different curvature. When the plane is parallel to the slant edge of the cone, then it's not going to hit both portions of the cone, only one portion of it, and you're going to have the parabola shape that you are familiar with. So this is the solid geometry base that this chapter is built upon. Although we don't really talk about the solid geometry anymore, all of the mathematics that we will be doing will be on this plane and just involve the x and y axis without getting a third dimension involved. We begin with a very short definition here of the circle, the set of points P in a plane, which are a fixed distance or a radius from a fixed point called the center. To draw a circle, you need that center. You need to know what the radius is, so that when your compass draws out the circle, and I know that's not just the best job I can do, all points on that circle are equidistant from that central point. And you already know that when it's not centered at the origin but centered at h, k, this will be your equation of the circle.